Okay, so let's start. Okay, so we have wasted around 12, 13 minutes into here and there. Okay, so we were about to talk about today. Alright, so today we are going to first talk about Uzi, then we will talk about our project. Okay, so the recording is running, we can see that. And alright, so hello everyone again. So as we have seen that in the whole ecosystem of Hadoop, there are many components, starting with HDFS, then we have MapReduce. So some of your work might involve MapReduce, HDFS, copying the data onto HDFS, or renaming the files, or deleting some old data, or the your other work might involve is your running MapReduce jobs, running pig Latin scripts, or after that you might have other than pig Latin you might have your Hive scripts or your Mahote scripts. You might have many kind of tasks to do in a project. Now, when in case of Java or any usual project, if we have different kind of works to do, then we basically run our Maven or Ant task. We run Maven or Ant task, and from that we are able to chain our things together. So in the similar manner, we have Uzi. Uzi is a workflow scheduler system to manage Hadoop jobs. So as we saw that everything, most of it is mostly the work is Hadoop jobs. Either it could be copying the data from HDFS, interacting with HDFS, or interacting with any other service. All of it is basically interacting with Hadoop, and therefore we need a special workflow scheduler. So in case of Uzi, just like any other workflow, any other like Ant, Maven, Make, in all of them, it's a jobs. Your task is a directed acyclic graph. What is a directed acyclic graph? We will describe in a minute. So there is Uzi also has other than what Make or Ant provides. In Make or Ant or anything, there is a configuration file in which we tell what to execute first and who depends on what. Alright. Other than those features, Uzi also provides you a coordinator. A coordinator a coordinator is a service which is running in the network, and coordinator basically is good for running things uh, periodically. So you might want to run your job based on availability of certain data, or you might want to run your jobs based on uh, time schedule. Okay, or you might want to run your job upon the completion of some other task, right? So those kind of things are very much possible using coordinator. And Uzi is very well integrated with the whole Hadoop stack. If it is not integrated, every now and then people keep on releasing plugins for Uzi which make it work together. Okay, Uzi is a greatly scalable system. It's very reliable and extensible system, meaning that Uzi jobs anywhere run in a network, and Uzi scheduler itself runs as a service. Okay, so An UZI workflow is represented as DAG. DAG means directed acyclic graph, meaning it's a graph of node in which there is a direction from one node to another, as well as it is acyclic, means there are no cycles. Okay, so although the term sounds very technical, but in normal life we encounter the DAG everywhere. In our normal life, probably everything we do is sort of a DAG. Say, for example, I get ready for office. So the task is to get ready for office. And what does it mean? It means picking up the bag. Before picking up the bag, I wear my shoes. And before wearing my shoes, I wear my trouser. And before wearing my wearing the trouser, I need to take bath, and so on, right? So there is a dependency involved in various tasks. Similar is my, on the other hand, to get ready means pick up the bag. For picking up the bag, I need to put on my shirt, and before, and then the whole dependency is there. Correct? So almost everything is, even in case of project management, we define tasks, we define the dependency of tasks, that this should start when this one finishes. Correct? And that's when that's when the dependency comes into play, and hence the directed acyclic graph come into play. And in case of our end task, we define that release means uploading the file, but before uploading the file, we should generate help documentation, and before generating help documentation, we should be compiling the code and zipping it. And once that is before that, before compiling the code, we should be preparing the directory structure and substituting the names in various folders, and so on. So basically, in case of an UZI task, in case of UZI task or AND task or Maven task, there is a dependency graph, and that is how we define things. Okay. Also, please note that each of these other the task on which we are dependent on, they are also executable. So when you have ant release, you have ant test, you also have ant make, you also have ant prepare, and there is a dependency, and you can call all of these tasks independently. Correct? And that is how it is. So, so you can see in this diagram, this looks like as if it has a cycle, but there is no cycle. And as you can see in our normal life, if there are cycles that to 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 wear the shoes, I need to wear the trouser, and to wear the trousers, I need to wear the shoes. If there is this kind of dependency anywhere, then we can never get ready for the office. Correct? In the same manner, this graph cannot have the dependency. Here it shows that 5 is dependent on 11, is dependent on 2, and 11 is dependent on 10, and 11 is also dependent on 9. And and that's it. So to execute 5, I need to execute 2 first, or 2 or 9 or 10. Any of these things have, all these three things have to be executed in no particular order. And after all these three things finish, you can see in this diagram, right? Here there is 11 depends on 2 and 11 also depends on 9, 11 also depends on 10. So to execute 5, we have to execute 2, execute 9, and execute 10, and once all these three are done, then we execute 11, and once 11 is done, then we'll execute 5 finally. Alright. Similarly, if we have to finish execution of 7, we'll have to execute 8, and but before executing 8, we'll have to execute 9. But if you see, so for execution of 8, 9 is also required. For execution of 11, 9 is also required. So this does not mean 9 gets executed twice. Okay, 9 get executed only once. The only thing is 9 will get executed before 11 or and before 8. Okay, so the execution strategy here, if you have to finish something called seventh task, okay, so 7 instead of 7, we could also say that to get ready for the office. We have to do this, we have to do this, and so on. Okay. So this is a directed acyclic graph, and you can see clearly there is no cycles. Do you see any cycles in this graph? Anyone? Okay, good, good. All right. So this is directed acyclic graph. Graph with no cycle. Almost all task executions are DAG, and there are many other examples. Now let's get deep dive into how does Uzi look like. Okay, it looks very ugly, but you have to bear with me here, and let me. You have to bear with me, and here. Okay. So is it visible to you? No. All right. So this is an example XML file in which we will be describing our actions. So every task involves multiple actions. An action could be action could be execution of MapReduce job, execution of pig script, or execution of something else. Okay, so this is our workflow application that we need to write. Okay, okay. So what does it say? It has a starting point. You can see the starting point here, and the starting point says that uh, everywhere, whenever Uzi is going to pick up this XML file, it is going to look for a tag called start, and start will tell which what is the action name that should be our entry point. Here, word count is our entry point. Once that is done, now it will start the execution of action. All right. Alright, it will start the execution of an action, and after that is done, then we will start basically the action execution means execution of MapReduce. Here is the definition of our MapReduce task. It basically says that we give it a name. Okay, job tracker means the location of the job tracker, so that it can call the job tracker and get the things executed. Okay, so this variable is picked up from the settings. Similarly, name of the name node is also picked up from the settings. So basically, execution of a MapReduce job involves knowing what is the name of our name node and what is the name of our job tracker. All right. In case of Yarn, job tracker is equal to resource manager. All right, and this is the configuration. The configuration says that the class name we have is this, and the mapper class is this, reducer is this, input directory is this, and output directory is this, and that's it. And once its action finishes, the if it finishes successfully, then it will execute another action called end, which is this one, and if it gets error, then it will execute an basically action named kill, and which is this one. All right, so this basically says, diagrammatically it says this. Okay, start MapReduce. If it is okay, go to end. If it gives an error, go to kill. All right, so that was an example of a very simple XML file involving a single job. Okay, similar to MapReduce, we can have many kind of actions. I will show you the different kind of actions that are possible using Uzi. Okay, so you have this kind of a diagram which shows you there is a starting point. It goes to the first, then fork means we want to execute second and third parallelly. We don't want third to wait till second finishes. Okay? And but we want to execute final when second and third have finished. Okay, so this kind of complex structure is possible. So for example, we want to first download a particular file, and so let's say we are downloading our ML movie lens data, while first one is cleaning up our rating. The second the third second one is cleaning up our ratings, meaning removing the double colon and putting it comma, while third one might clean up our other task, user dot data or movie dot data. All right, so all these second and third will execute in parallel, and once both of them are done, say we want to execute finally Mahout task. Okay, we want to give those details prepared in second and third step to Mahout finally. And once that is done, we want to give it to either end. If there is an error, it goes to kill. Okay. And also note that kill is like a ground. Any task, if it fails, then the whole process goes to the kill. So here it is, you can see that. So start to, if the same thing, if you have to write in XML, this is how we are going to write. All right. So although you would never need to write this kind of XML, I will show you how to do it from the UI. Okay. So we can run our Uzi task using these set of commands. So first we will say login into Hadoop 2 today, and then we will just take up the standard examples provided by provided by Uzi, and we will basically extract it. Under that there will be an examples folder. We will upload that examples folder onto our HDFS. Okay, so and after that we will edit our job.properties so that it points to our servers, and then we will execute our Uzi job. So you can see clearly that even our XML files will be uploaded onto HDFS. Okay, so I think it should be already there. So let me first check if our Uzi is running. Yeah, Uzi seems to be running. Alright, now let's say I go to HDFS. Let's just check in HDFS. You must have already uploaded these examples into this folder. Yeah. So here we have, this is the structure. What we are going to do, we are going to tell the command line Uzi job, and then we are going to give the URL of the Uzi server, which is running at this particular port, with the config as this one. So here we have config at located at apps slash mapreduce, app slash mapreduce. So these are various examples which you can try out. Okay, mapreduce. Okay, so somebody seems to be joining. Okay, so here we have examples apps, and then we have mapreduce job properties. So this is the one which we need to add it. So right, I have already edited it. Okay, like this. So basically for each project you will create this kind of a folder, like we have MapReduce folder, which will have the libraries, whatever libraries you want to put in. Second, it will have a job properties like this. And third, it will have the workflow, Right now the workflow is simply a map reduce job. Okay, simply a map reduce job. And what will it have? The library will have your mr code, whatever the one which we were running earlier, that is the one it will have. Okay, so there will be a map reduce folder. For each project you will create a folder in hdfs. Note that it is in hdfs, it is not in your local file. All right. Also please note that in case you are running a larger project, so here what we need is we have to create these set of files, and then we have to run it using this kind of a command. All right. So this way we will get some data, and we will also be able to run some sort of examples. Okay. So this job.properties we have shown you. It has the name of the name node, job tracker, queue name. Queue name I've put default, and some the other one. The output directory I've put here, and then we have these variables. Whatever we have in job properties, we can use them in the workflow file. Like job tracker we are using here, name node we are using here, queue name we are using here as the variable, so that we don't have to hard code those values into this XML. Okay. So let's get on to the second server. SSH student hadoop 2.nobigdata.com, and what we have afterwards we can basically pick up. Alright, so this is one way of executing task. So what does it say? It says Uzi this, config is this. We can say here, let me just clean it up. Remove spaces, replace with nothing. Alright, let me edit this. So it says the configuration file not found. Job.properties, user, student, and this. Okay, let me try to copy it locally. Is it looking for this to copy to local? Is it there? It's in the same folder, right? Job.properties, that's correct. So it has executed a Uzi job and is trying to run it. Okay, so it says the name node URL MapReduce. Yeah. So looks like the job.properties have to be locally available, and then you can basically run it. Alright. So on the other side, this is where the jobs will be listed. You can also check the what's going on with your job by using a command like this. Okay. So when we started the job, it gave the status of our job like this. It says start is okay and it's preparing. Alright. So this is the one which is currently running, and it says that start is okay. It's preparing the map reduce, and then it's going to go ahead. Alright. The progress is 50%. So here it is trying to execute probably. Yeah. You can go further detail into this. There are no child job, and this is the XML which we have given it. Alright, so we can also execute our own MapReduce in the same fashion. Are you guys with me? All we need to do is say go to apps folder, whatever is there in the MapReduce, we create our own folder, and we in the workflow.xml, we'll mention our mappers and reducers. In the workflow.xml, we'll mention our own mappers and reducers, meaning first you download this file, once you're done, you upload it back. Alright. So that's one way of executing Hadoop tasks. Okay. The other way, other easier way, this was the harder way. This was the harder way. Other easier way is to use the interface. I'll show you after this screen. So there are other MapReduce tasks such as this one. Is the voice breaking for everyone? For everyone it's breaking. Okay. Alright, so looks like today the network is giving trouble. Alright, so is the voice still breaking?